Hello, welcome back to Chapter 10, Section 1, Organizing and Displaying Data. In this example, we're going to talk about line graphs. In the next example, we'll talk about double line graphs. We'll do them one video at a time. Now, here's the important thing about line graphs. Line graphs always use time. Time. In this case, we're doing midnight, 4 a.m., 8 a.m., noon. Sometimes it's hours or minutes. Sometimes it's days or months or even years. In the previous video, I'll pull it up over here. In the previous video, we had times because we had years. But I also tried to explain that that's really not what this data is about. This data isn't about the year itself. It's about the season, the football season or the basketball season. In here, we are actually measuring time. We're keeping track like we're looking at a clock. And the other measurement that we're paying attention to is the temperature outside. So this is demonstrating watching the temperature change throughout the day. And it kind of makes sense. Midnight, you check the temperature, it's a little bit below 60 degrees. 4 a.m., starting to warm up. I don't really think that's the way it happens in the real world, because I think it gets cooler until the sun comes up. By 8 o'clock a.m., the sun is starting to come up, so it's starting to get a little warmer. And as it gets closer to noon and late afternoon, then it's going to get warmer, and then it looks like it's starting to slightly cool down again, which is pretty typical. At what time was the temperature the warmest? Well, according to this graph, the temperature was at its highest peak right here, which is at 4 o'clock p.m. During which 4-hour time period? What does that mean? Well, everything's on 4 hours, from 12 midnight to 4 a.m. to 8 a.m. to 12 noon to 4 p.m. to 8 p.m. So each of these blocks is 4 periods. During 4 hours, excuse me. During which 4-hour time period did the temperature increase the most? Okay, so there's two ways of doing that. One way is to actually estimate what each of these are. This looks like it's probably about 50, I'd say about 58, maybe. This is about 62 or 63. This looks like it's maybe, I don't know, maybe like 70-ish, or maybe 71. It's halfway between 60 and 80. That looks like it's exactly at 80. This is maybe a little bit higher, 81 or 82. And this is, it's really hard to tell, but it's a little bit below that line, so it's about 70. So you could actually go through and estimate each of the temperatures using the graph, and then just find out which one it increased the most by. However, here's the reason why we use a picture and not just listing the numbers. Way back in Chapter 5, we talked about linear functions. And we talked about slope and the rate of change. So I'm going to exaggerate a little bit with this ruler. But if my line, and none of them are, but if my line was perfectly horizontal, that means no vertical change. So there's no change in the temperature. The vertical measurement is temperature. There, that thing happened again where I put it, it's missing the U. But if the line starts to slope upwards, that means that it's increasing as you go to the right. So as time increases, the temperature is increasing. If it slopes down, that means that temperature is decreasing as time is increasing. So I know it's not going to be from here to here because that's getting cooler. I want the increase. So what I'm going to look for, and it's really kind of hard to see, I'm going to look for where the steepest slope is. And it looks like these two are actually pretty consistent. But this one, slightly higher slope. That one, not so much, and then this one has negative slope. So it looks to me that the 4-period time would increase the most was from 8 a.m. till noon. And again, you can check by looking at the numbers However, the reason why we have a picture is so that we can use the picture of the lines so that we can actually make that decision without doing any complicated calculations. All right, we'll see you in the next video.